This problem. And how we have a plus C, correct? Okay. Obviously, mathematicians don't like things like that hanging out. If possible, we want to get rid of them. So there are a couple ways to get rid of those. I'm going to show you one today. It's called using an initial condition. Okay. So an initial condition is just all that is it's just a point on the graph. So what we're going to give you is a derivative and a point on the original. You're going to be able to solve for where that plus C should be. Okay, that's all it is.
So it's going to say 11 over 5?
Yeah, it's the same problem we did over there on the board. So an initial condition is just some information to help you solve for whatever the constant might be, plus C. So what's the best way to do this is to give you an example. Okay, so you're given a derivative 4x to the 7th, and this is your initial condition here.
Is that a 0 in the front?
It's a 0, yeah.
Alright.
It's not a sideways 6.
Well, I don't know what I thought it was, but I did not think it was a 0.
So basically what we're doing now, when we calculated this function, we had no way to tell where it was placed up and down on the y-axis. This is telling me that y goes through that point 0,4. The function goes through 0,4. Okay. So now I'm going to get rid of the c because I know where to put that. So. Let's see, integral of 4x to the 7th, or the antiderivative of 4x to the 7th. Yeah. Oh, you missed something. There you go. Which is the same as x to the 8th over 2. Correct? Okay. So if we use the initial condition, don't use your mental condition. Yes. Okay. So this is the function y equals. We had a derivative, we did the antiderivative, now we're at the original function, correct? So this is the original function.
Wait. Oh, using this
Question?
How do I use the initial condition?
Plug that point in.
Plug the point in. Yeah, solve for C.
That's it.
Yeah, that's it. The y value is 4, the x is 0. Solve for C.
Well, that's not that bad.
No, it's not. See, I was honest. I said it's easy. Well, guess what?
It's actually easy.
Right? You agree with that conclusion? Okay, so what is y equal to? There is
Hey, look.
Now you have solved dy dx subject to the initial condition that's given. You have the actual function.
So you put his 4 in. X and Y.
Go ahead.
No, the y value is 4,
Oh, at 0.
and the x is 0. 4 and 0. Okay. Would you like to see a trig function?
Sure.
Okay. Give it a trig function. I wasn't here. I had you watch a video. This was last Wednesday
Yep.
on how to deal with that.
Yep.
Okay, so the antiderivative of sine pi t.
I wrote that.
How do you deal with that? Okay, so antiderivative of sine. You get cosine, pi t, and how do you deal with that in there? Because it's a chain rule issue, correct? Hopefully the video was clear about it. Anybody? Trying to gauge how effective that video was right now. Divide by. Yep. There you go. So again, the derivative chain rule, you would multiply by the derivative here, correct? Times pi. Well, the antiderivative you divide. Okay, again, very nice. And then we don't want to forget
Plus C.
that. And then plug in your initial condition. And the unit circle. Is that right? Somebody just mumbled it in my ear. I don't know if I trust that. I'm pretty sure it's good. Okay, so add, right? There's your constant. That's not, we're not in the rodeo, this is not right.
Yeah.
Right? And then write your function.
Is this going to be on the test tomorrow?
I already answered that question.
See, look at the review.
I did, I answered it.
You said it like you should.
I did, I said it several times. There you go.
Yeah.
Is there part, is this something you can do in the calculator?
No.
That's
Well,
not too bad.
this would be a non-calculator problem, guaranteed. Okay, word problem real quick.
Word problems are
Okay, a car traveling with velocity 24 meters per second begins too slow at time 0 with constant acceleration -6 meters per second.
That's what it was.
Okay, that is
I have negative 16.
negative 6 meters per second squared. Yeah. Fine. The velocity function. That was rude.
What?
Yeah, but he didn't.
That was okay. So, you have some information here. Velocity is 24 at time 0, and the constant acceleration of negative 6 meters per second squared. Where are we going to start?
What to ask you for? With a T?
Yeah. So we want the velocity function. Do we have enough information just to write that function?
Guessing not.
No, we don't. Okay, but we do have the acceleration. Okay. See, if you look at this info, that's just a point, 0.24. That's an initial condition. Okay? That's just the information at one instant. This is information over time. So we can actually write a function for acceleration. Okay. No, it's a constant. Sorry. Constant acceleration. No, not dependent upon time. Okay. So how do we move the velocity from acceleration? It's the antiderivative there, right? So let me write that up here. All right. Correct? Now use your initial condition. Because this is the velocity function, right? You've antiderived acceleration. Now use your initial condition, plug it into the velocity function to find your constant. And there is your velocity function. Could you calculate the position function from that? How would I calculate the position function? Antiderived velocity, right? Do I have an initial condition to get rid of C there? I don't. Okay, so my position function would have a C in it. But again, recognize that relationship, derivatives, and now we can do antiderivatives, correct? There you go. Any questions? Okay. I am not going to ask you to finish the work because I'd rather you study for your final. Okay. So, but we're going to hit this pretty hard. This is all next semester is all antiderivatives. So just keep in mind how to use initial conditions and you're good to go. All right?
Give me 2 minutes.